To solve an inequality in two variables, we need to graph it. First, replace the inequality symbol with an equal sign and graph the line. If we have less than or equal to or greater than or equal to, we use a solid line. If we have strict inequalities like greater than or less than, we used a dashed or dotted line. Next, we'll test a point from one of the sides of the line, but make sure we test a point that is not on the line. We'll use the coordinates of that test point and plug it into the original inequality. If the test point makes the inequality true, we shade on the side of the line that is true. If the test point makes the inequality false, we shade on the other side of the line. For example, let's graph this inequality. Start by changing the inequality to an equation. Let's isolate y in order to graph this. We'll subtract 2x on both sides and then divide by -4. Y is equal to 1/2 x minus 2. Let's graph this line. The y-intercept is -2. The slope is 1/2, so up 1, right 2, up 1, right 2, or we could do the opposite, down 1, left 2, down 1, left 2. And then make sure you ask yourself, is this a solid or a dotted line? In this case, the original inequality had equal to, so this is a solid line. Now that line split the graph into two regions, one above and one below. One of those regions is true, one of those regions is false. We need to choose a test point to determine which region is true and which is false. You can choose any point you want as long as it's not on the line you just drew. The easiest point is going to be the origin. So let's test the coordinate 0, 0. We're always going to test in the original inequality, which is 2x minus 4y is greater than 8, greater than or equal to 8. Plug in your test point. And we're asking, is this a true statement? 0 is greater than or equal to 8. That's a false statement. Right? We chose this point and it was false. That means the other side has to be true. So everything below the line is part of our solution set. In this example, we will start by changing the inequality into an equation. -3/4 x. Let's graph that line now. The x-intercept is 0. The slope is -3/4, so we'll go down 3, right 4. Or we could do the opposite. We could go up 3, left 4. And when we play connect the dots, make sure you use a dotted line because of the strict inequality. It's easy to forget to do that. And notice that that line splits the graph into two regions. One is true, one is false. To test which one is which, we need to choose a point. It can be any point you want as long as it's not on the line you just drew. Typically we use the origin because it's quick and easy, but this time the line goes through the origin, so we can't choose it. So choose any other point. It doesn't matter which one you choose. I'm going to choose, let's say 4, 0. And let's test 4, 0. We're always going to test in the original inequality. So y is 0. We're asking, is that greater than -3/4 times 4? 0 is greater than -3. That is a true statement. Since this point is true, that means every point on this side of the line is true. So shade the part that is true. And every point in that shaded region is a solution to this inequality.